Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department, and today we are going to discuss the topic addressing mode with the subject Computer Organization and Architecture. And it is very important topic, and in this part I am also covering the numerical part also. There are different type of addressing modes are there. First of all, we will discuss actually what is addressing mode. So before starting the what is addressing mode, we have to know what are the operands and opcode. What are the operands and opcode? Suppose that there is a C equal to A plus B. Suppose this is the simple example, the C, A and B, these are the variables in which you are getting some particular result, and the result will be stored in the C, and A and B where you are applying some operation, and the operation is what? That is plus. It means what? Here the two terms are there, that is first one is the operand and the second one is opcode. Always you have to remember that what are the operand and what are the opcode. Operands are what? The variables on which you are going to perform any operation, that is called the operand, and the opcode, whatever operation you are going to perform, that is the opcode. It means what? Here A and B are the operands because these variables you are performing some addition, and then what operation you are going to perform, that is the plus sign. It means what? That is the opcode. Just as an example, if I am saying that is open file1.txt, it means what? Here which type of operand and opcodes are there? Here you can see here there is a file1.txt. File1.txt means there is a some text file is there on which you are going to perform the operation open that particular file. So here this open is what? That is the opcode, and on which you are going to perform the operation, that is the file1. It means here that is the actually operand and open is the opcode. So addressing mode are what? Addressing mode are actually finding the effective address of the operand. Now the new term is introduced, that is the effective address. What is the effective address? Effective address is that actually where the operand is residing. Either it is in the memory or a register, then it is called as an effective address. So finding out the operand address or an actual address where it is residing either in the memory or a register, that is called the addressing mode. You can say the addressing mode is a way to find out the actual address of the operand. Fine. And this particular address of the actual address, that is called the effective address. So you can say that is it specify the rule for interpreting or modifying the address field of the instruction, or there are so many addressing modes are there, like the immediate addressing mode, indirect, and further on we are going to discuss. The first of all, this is the computer instruction format, or you can say that is the instruction format. In the instruction format there are three fields: opcode, mode and address. Opcode, now you can understand. Mode, there are 10 types of addressing mode are there, and address, that is the computer instruction where actually it is what is the address of the instruction. You can see here, suppose that this is the memory, this is the memory, and your file is here f1.txt. This particular file is there and its address is 2004 because it is a physical address. This 2004, when fetching from MAR to IR register, this address, because this address is how you are going to read. This is currently stored in the MAR, means memory address register, and it is going to fetch into the instruction register, and this computer instruction contains opcode, mode and address, and this address part of the instruction is stored here. So means here this 2004 is the address. Now in the easiest way, what are the computer instruction format? That is the three parts, or you can say the three fields are there, that is opcode, mode and address. Opcode, on which whatever operation you are going to perform on the operand. addressing mode, finding the way to find the effective address of the operand, and the address is the address of the instruction which is going to be executed. That is the address part. Now you can understand this. There are different type of addressing modes are there. That is implied, immediate, register. One by one we can discuss with the example that what are these types. That is direct addressing mode is also there, means actually the operand is residing in the memory. If it is not residing in the memory, then it is called the indirect addressing mode. I am giving a simple example so that you can understand easily. Suppose that you are sitting in a class. You are sitting in a lecture hall. In this lecture hall, there are the 60 students are sitting. Fine. There is a classroom. Suppose that this is the classroom is there. This classroom name is, suppose this classroom name is CR. Fine. I want to search any particular students, and there are so many students are there, and sitting like 3 next and the 60. These roll numbers are sitting. Suppose that I want to search the fifth student or a roll number 5. First of all, where I have to go? At that moment, even though that particular student permanent address is their home, but in this particular time when the lectures are going on, that particular student can be found into the class. We can get there. It means what? The actual address or the actual location at the time of the classes, the student is that particular classroom. Means if I want to find this particular student, it means I have to go here in the classroom and I can get that student. This is called the directly I can get that particular student. Directly I can get. Suppose that this is the student. Suppose that I want to search this roll number 6. This particular student is actually sitting in the canteen area. Suppose that he is sitting in the canteen area. Up now, how you are going to set? This canteen area is there, not in the classroom, but actually that particular student should get into the classroom. Now, when I want to search that particular student, I am going there in the classroom, and then the student friends are saying that actually this roll number is sitting in the canteen area. It means what? I can get that student location indirectly. Then it is called the indirect mode. Now you can understand that there is a direct mode and indirect. If you can get directly fetching to the operand, then it is called direct mode. And if it is not getting the directly, then it is called the indirectly mode. Means operand are not fetching directly from the memory. Then it is indirect mode. Either it is the indirect addressing mode of a memory or indirect register mode. Fine. And the next is the implied. Now take an example that if I am saying just write down the C programming. Everyone is already studied in the first year classes in the class C programming. If I am saying C equal to A plus B, just write down the C program. Fine. In this particular time, you are not going to search out that actually what is going on. Means what? In this time, you are not searching your mobile or any resources. You are just writing that hash include and something and you are writing the complete program, complete 4-5 lines program. It means what? Implicitly, it is defined inherently. Implied mode is that when the particular instruction address or a operand address is implicitly defined by the computer instruction, then it is called the implied mode. Immediate mode, when the operand value is the address field, then it is called the immediate mode. And register direct and indirect we can consider with the example. Fine. Now the one by one we can understand. The first is the implied mode. In the implied mode, you can see here the opcode, mode and address. Operand is actually implicitly defined or a implied. Implied or implicitly defined is the same. Fine. Now, in the immediate mode, specifying the address. The address part of the instruction is actually the operand. Opcode mode and address is there, na? The address part of the instruction is actually the address of the operand. That's why it is called the immediate mode. Simple. And the direct addressing mode, when I am taking the example that that particular student is in the classroom, even though permanent location is his home. Now, when I am searching the operand, that particular operand is residing in the memory, and this address part of the instruction, suppose that this address part is 400. And here in the memory, whatever value is residing here at the address of 400, then it is called the, we can get the actual address of the operand. So now, actually the addressing mode is what? Finding out the effective address of the operand. And effective address is what? That is, the operand is where operand is actually residing. Either it can be in the memory or in the register. So now the effective address is what? This effective address is there. It means in this time the effective address is 400. Now in the indirect addressing mode, indirectly we can find out. Indirectly we can find out means, as we can take the example, that particular student was sitting in a canteen area, but I can get that particular information from the classroom. Indirectly, I can get the information that student is sitting in the canteen from the classroom. This is called the indirect. You can map it here. Instruction address is again the same. Suppose that the instruction address part of the instruction is 400. I can get this particular 400. And suppose in this 400, there is a 600 values there. Means this 600, this is the operand address. Now, the effective address become as a 600. It means what? Indirectly, I can get the information. If it is the classroom, then classroom boys are saying or girls are saying that particular student is sitting here in the canteen area. And this canteen area address is this 600. Now, you can easily understand and easily correlate with this example that how you are going to find out the actual address of the operand. Now, next is the register mode. You can see here that is a register mode and the register direct addressing mode, both are the same thing. Now, in the register addressing mode, the same procedure just like the direct addressing mode, only the difference is there. Now, the operand is residing in the register instead of the memory. Now, there is the address of the part of the instruction, and this operand is going on in the register set. Means that operand is actually residing in the register, not in the memory. That is the only difference. Then in the indirect addressing mode, same as indirect addressing mode. That is a register indirect addressing mode. That instruction specifies the register which contains the memory address of the operand. Here you can see here, just like this is the register and there is a memory, and this register value, suppose that this is the 100 values there. This 100 value contains this here. Suppose that this is the 300. This 100, we can get that instruction that in this time I am not getting the operand. I am getting indirectly the address of the operand. It means what? Now, this 300 operand address is there. That is the indirect addressing mode. In the auto increment and auto decrement mode, we are calculating with the address. Address part of the instruction -1 and address part of the instruction +1. That is the auto increment and auto decrement mode. There is a relative addressing mode or a base register mode. In the relative addressing mode, we are again getting this effective address, this one. We can get this PC plus instruction content part of the instruction address. PC is what? Program counter. And what is the program counter? Means actually which particular instruction is going to execute it next. That is contains by the PC or a program counter. It is just like that and in this time the classroom teaching is going on, the one particular subject, suppose that data structure is going on, and the next class is the DSTL. So the PC contain the address of the DSTL, which particular class is going on to the next. So that is what PC. PC is the register or a program counter that which particular instruction is going to executed next, it contains that particular address. Now, in the displacement or a base register mode, we are actually plus. There is a appending is there. Now, this is the example that's why I'm taking this numerical. Actually, this numerical is coming into the sessionals and semesters always. So first of all, we have to read actually what is asking about. Now you can get that there are 10 type of addressing modes are there. Implied mode, immediate mode, direct addressing mode, indirect addressing mode, and also there is a register direct mode and the register indirect mode, index register mode and the base register mode. Base register mode is also called the replacement mode. Fine. So now we can get all these 10 register mode with this particular example. First slide. Consider a two-word instruction. Here there is a writing it here, that is a two-word instruction. Now you have to note this instruction that we have a address field of what? We have a opcode, mode and address. We have three fields, and if they are asking about the two-word instruction, computer instruction part is two-word. Now, first of all, before starting the solution, first we have to know what is one word, two word and three word. If there is a one word instruction, so how you are going to write? If there is a one word instruction, there is a memory and you have to write, because the one word instruction, it means it will be stored in a single address. Means suppose that this is a one word instruction is stored in the 561. This 561 is written over here, and this particular address is the opcode, mode and address. This is the compute one word. If there is a two word instruction, there is a two word instruction. Two word instruction means what? If there is a two word instruction. First of all, three word, after that I am going to the two word instruction. So you can understand easily. If there is a three word instruction, in the three word instruction, one word instruction means it will be stored in the single address. Three word instruction, suppose that it will be stored here in a 700, 701 and 702. These are the three word. And you know that there is a opcode, mode and address. It means what? In the first address 700, 701 and 702, there is a opcode, there is a mode and there is a address. Simple. Opcode, because the three address you can map it now. Now the two word instruction, generally your question coming into the two word instruction. If the question is coming at one word instruction, so you can follow this, and if there is a three word instruction, so you have to follow this one. But now in the question there is a two word instruction. Now the solution will be started from here. Our question is two word instruction. The two word instruction means what? There is a only the memory locations are two. In the memory location, it will be stored at 200 and 201. Because the two word instruction means it will be stored in the two address location, 200 and 201. But the challenge is what? I have a computer instruction of the three fields, and you have to accommodate these three fields into the two values. Now, the restriction is that when the two word instruction, the first two parts of the computer instruction format, you have to combine it in the one location, that is opcode and mode, and in the next there is a address. You have to remember always. And why this is the writing it here, that is because that particular location combining two values, 200 and only 201. and I have a 3 instruction field, that is opcode, mode and address. So I have to take it out, the first field, second field as a combine in a one location, and the second location there is a address. And the restriction is that you cannot combine you cannot write like first is the opcode and the second one is the mode and address. This is wrong. Fine. So always you have to combine the first two fields of the computer instruction format, that is a opcode and mode, and the second one is the address. Fine. Now we can go for the address part of the instruction is 500. So you have to know the address part of the instruction is 500. Index register value is given, register value somehow so many times there is a register, in the register part there is a XR register, you can see here, and somehow the particular effective address means you have to calculate the effective address. Now this will be the question. Now we can consider that which particular instruction how you are going to apply. Fine. Now first of all you have to create the memory. First of all, you have to create the memory, and in this particular memory, you have to 200 and 201. So you have to write it here 200 and 201. The first thing is opcode and mode. And the next part is the address part of the instruction is 500. So just simply you have to write this is 500. This is only the question is there. Fine. Suppose that the instruction is load to AC. This is the computer instruction load to AC. Now, one by one we can go for this. Suppose that the first thing is implied mode. In the implied mode, you can find out the effective address, and in this effective address, you have to calculate only where the operand is residing. In the implied mode, there is no effective address. Only you have to write down the applicability or a non-applicability. Applicability and non-applicability means, first of all, you have to check which type of instruction is there. That is load to AC. Load to AC means what? In the accumulator, you have to store something, but you don't know actually what is going to be stored. That's why here we can write that it is not applicable. Simple. This is not applicable. It means what? The load to AC. If I am writing there ASHR AC, suppose if the instruction was ASHR AC, it means what? Whatever content is stored in the accumulator, you have to arithmetic shift right. Arithmetic shift right, it means what? In this mode, implied mode is applicable. So depending upon the computer instruction, you have to understand the which type of mode is there, applicability and the implied mode or a immediate mode. Now the second is the immediate mode. In the immediate mode, whatever the computer instruction format is there, means address part of the instruction is actually the effective address. So you can simply write the effective address is what? And in the accumulator. Why I am taking accumulator? Because the instruction is load to AC and the register name is AC. So in the AC, there is what? Operand is residing. It means what? Now I can get the 500 as an operand. And the effective address what? This 500 is stored in the location at 201. Means what? This is 201. And the third, direct addressing mode. In the direct addressing mode or a direct memory addressing mode, we have to understand that there is a opcode, mode and address is there, and this address part is saying that there is a operand is there. Means here address part of the instruction is what? That is 500. In this here, you can see here, that is the 500. It means what? At the 500. you can find out the effective address in the direct addressing mode. Now, how you can find out? Now, the tricky part is there, because in this particular question, now there is you have to assume something. And whenever you are going to assume, there are three values. You have to write down this when you are assuming the operand, because at the time I know the location of the address, but I don't know what is the operand value. So here you have to assume that of the operand. And how you are going to assume? It should not be replicate. First thing means what? Replication is not possible, means whatever addresses are given, suppose that 200, 201, 500, 100, these are the values. Instead of these, otherwise you can take some other values for calculating this operand value. The first thing. Second thing, if there is a 3-digit values are there, whatever the number of digits are given as the address. Here you can see here there is a 200, 201, 300, 500, these values are given. It means there is a 3-digit value. It means this digit values should be same. The second thing is there. Now next one is, it should not be replicate and the digit values will be same. Somehow you can take, because these are the numbers, you can see the whole number 400, 200, so you can see 221, 231, something like that. Fine. Now, in the direct addressing mode, you have to assume now, suppose that there is a 500 value. In this 500 value, this particular value address part of the instruction, suppose that you are taking 319. It means what? Effective address is the 500, and now the operand value in the accumulator, what is going to be stored? That is 319. This is the direct addressing mode. Now, in the indirect addressing mode, that particular instruction is, suppose this is a computer instruction, opcode mode and address is there, and the address part, now address part is not going to find out that actually this is the operand. This particular address, because I have a 500 of 319, now this 319 says actually there is the operand. Fine. That is called the indirect addressing mode. Now here the 500 and this 500 in the 319, in this particular, you can see that is in the 319, some address is there. Suppose that is the 222. Means what? In the effective address is what now? That is 319. And in the accumulator, what is going to be stored? That is 222. And you are going to assume. Fine. Now, in the register direct addressing mode, actually it is stored, but in the register direct addressing mode, that particular instruction means the effective address is not applicable here in the register direct addressing mode. And in the operand, it is stored as what? The register value is 400 is given. So here 400 will be there. And in the indirect register addressing mode, in the indirect register addressing mode means what? Actually now here effective address is 400, and in the accumulator, the 400, somehow there is a 400, suppose there is a 400 values there, somehow this 400 will be stored as a 712, suppose. So this particular 400 will be stored here as an effective address, and here that is 712 is there. Effective address is there. Indirect addressing mode is there. Now the next one is the index register mode. In the index register mode, you have to calculate the effective address. Effective address means what? Content part of the instruction, that is 500 plus index register mode is 100. So the effective address is 600. Fine. In the relative addressing mode, effective address is the PC plus content part of the instruction. PC is what here? That is, this is the next instruction. The next instruction will be executed here as a 202. So the relative addressing mode, there is a 202 plus 500. That is 702. And the next is auto increment. Auto increment mode is same as a indirect addressing mode. Auto increment mode means what? Here effective address is 400 and the accumulator will be stored 712, and after the instruction execution, effective address will become as a 401. And in the auto decrement mode, you can see there is what? 400 is there. So effective address is 399, and in the accumulator at the 399, whatever value is stored, that is in the auto decrement mode. That is the auto decrement mode. This is the addressing mode example. Thank you.